All right, in this video, we're going to be solving for x given 4 minus 5 times the absolute value of 3/4 x plus 12 equals 4. Now, one of the things I'm going to do is I'm going to rewrite this function or this equation so it's a little bit easier to read. The 4, I'm going to move it to the other side of the absolute value, but I'm also going to do something to the inside. So we're going to rewrite it as negative 5 times the absolute value of 3/4 parentheses x plus 16. Close it. Plus 4. And that will equal 4. Okay, now for this part here, where did the 16 come from? So in order to write the function where it was 3/4 of x plus 16, what we had to do is we had to take this 3/4 out, because keep in mind, this 3/4 of x is only affecting the x right now, but the b value should actually be affecting everything. So what we're going to do is we're going to factor out 3/4 from each of these terms. So we are factoring out 3/4. Well, it's easy to factor the 3/4 off of the x, but what happens here? Well, this becomes 3/4 of x plus, we have to take it by its reciprocal. So this is really 12 over, and we're going to take the 4 over the 3. This is going to reduce, I'm going to go ahead and close the bracket here, in the parentheses. This is going to reduce to 4, and that reduces to 1. And then you're left with 4 times 4, which is going to give us the final modified part on the inside of the absolute value is 3/4 of x plus 16. And that's where the 16 actually came from. We had to factor out the 3/4 to really see where the vertex is at. It's not at 12 for the x value, it's at positive 16. 4. Okay, now for this part here, our a is negative 5. Okay, and what does that negative 5 actually refer to? So the negative 5 tells us this has a vertical dilation by 5, and it's also vertically reflected. So vertical dilation by 5, and it's vertically reflected. So it's going to open downwards. That's what that's telling us right there. The b value is 3/4. And all that's telling us is we have a horizontal dilation by factor 4/3. So we are actually stretching it outwards. So we're just taking the reciprocal of that. The h value changed to 16, and we'll see. I have a little short snippet on where that 16 came from. But this is telling us a horizontal shift. So horizontal translation left 16. And then a k value being 4 tells us a vertical translation up 4. So here's another reason why we do this. So this 4 that's in the function or in this equation, this is a constant amount. So we're going to take our graph, and the reason I had the little graph here is we're going to try to generalize how many solutions we could expect from this graph. So this is at 4. And we're saying the left side is equal to 4. And from this, the reason I did this is we want to be able to pull the vertex out of this function. So we're going to go 16 units to the left. So the vertex is going to be at negative 16, 4. It's the h, the opposite of h, so negative h, and you keep the k exactly how it is. So we have negative 16, positive 4. And so then when I go to the graph, I'm going to go to negative 16. It's somewhere over here. I'm going to go all the way up to 4, and you're going to see it touches the line. And then because it's opening downwards because of the a value, this is going to tell us that we're expecting one solution. And it's exactly on the line. And just from that graph alone, this should tell you exactly what the x value should be, our value for x that we're looking for. Okay. So how do we find the solution? So one of the first things you want to do is to take that function, and I'm just going to take it how it was originally. I'm not worried about all of the translations and stuff like that now, but it was just an idea of figuring out where these solutions are located at. So we're going to take that solution, and we have to isolate this piece right here. And to do that, the first thing we want to do is subtract 4. So this is going to translate the graph down 4 units. Okay, so keep in mind, right? We had the graph, it looked like this. We had our function, it was opening downwards. So we're going to take this function now, it's going to read out as negative 5 times the absolute value of 3/4 of x plus 12. And now that equals 0. So now our horizontal line has been shifted down to the 0, and our graph is still opening downwards. The next step is to then divide. So what we're doing is we are dilating by 1/5, and we are reflecting over the x. So that's the negative 1/5 part. So this is going to give us a new function of the absolute value of 3/4 of x plus 12. And if you divide 0 by a number, you're going to get 0. So now the graph is still going through, or the constant amount is still at 0. But now we have a graph that's not as vertically stretched. Okay. Try that again. This does not need to be exact, but it's just squeezing it back down to its normal amount. So if I had gone through the graph here and I could have done that a little bit better, this would have been vertically stretched. Okay, now the final part of this graph, it looks normal. It's now stretching, or not stretching, it's just normal. And it's reflected over. So now we have the value where we're looking at, and keep in mind the absolute value part of it should equal 0. So we're going to take 3/4 of x plus 12. There is no positive 0, there is no negative 0. So we're just solving for this piece here. So we can drop the absolute value. We can set it equal to 0, and then we just solve for x. So minus 12. We're going to get 3/4 x is equal to negative 12, and then we're going to multiply by the reciprocal. That's going to allow us to change that to 4. This goes to 1. And this is going to give us a solution of -4 times 4, which is -16. And that number should look familiar. X equals -16. If we go back to the vertex value was at -16. Remember, it was directly on the line like we expected, and that is the only solution that would work in this case. So how do we check it? So what we're going to do is we're going to take 4 minus 5 times the absolute value of 3/4 of x plus 12. And we're asking, does that equal 4? So if we plug in -16, 3/4 of -16, that's going to give us -12 plus 12. Multiply that by -5 and we'll add 4. Okay, 4, the inside of this is going to give us 0. 5 times the absolute value of 0, which is 0. This gives us 4 minus 0, and 4 minus 0 is 4, and 4 equals 4. So this is a great solution. And that's through the process.